So now we are going to see about deletion operation. Okay, so here also the node may be altered in the list, so we have to return the head always after end of the each operation. Here also there are three operations: delete the middle, first and last. We will see one by one. First delete delete at the first. Okay, node star delete first. Delete first. Again you are taking the argument as header. So inside we are going to do the deletion operation. So first node has to be removed. Okay, the first node is actually pointing out the head node. So we are going to get the reference to some temporary variable because that is should be removed from the memory allocation. So what we have to do, it's very simple. You have to, if you want to print the details also, you may print. The process is very simple. We are going to take first t equal to, that is the temporary variable t equal to header. Okay, after that we are changing the header to the next position. Head equal to head of next. Now head is moved from first node to second node. So hereafter we don't want the first node. You can simply call free of that t. That's it. After that you can simply call return of header. That's all about delete first. Okay. If you want, you can print all the values, whatever the node you are deleting. If you want to print those details, means you can print after here. The deleted node data and name. The help of the t reference, you can print that also to the user. Okay. The next operation is node star delete middle. For this, you should ask one input from user. What we did for insertion middle, similar. How to get one input from user for which node how to delete. Okay. It's a function. So you are going to get the reference of two things here for doing the deletion operation. Somewhat you should be careful also here. Node star of previous. Previous is a variable pointing to the node which is previously present in the deletion node. The next one is the current node, what we have to actually delete. Current or the two nodes. Okay. After that you can go for now. You are going to ask the user. Enter the data value of the node to be removed. This is for getting the reference of the node which one is actually removed from the linked list. Okay, so we have to get this input from the user. So you can go for scanf percentage d, because it is a data as the integer data, comma ampersand of input. We are going to get some input from the user, so that should be declared. Am I correct? That value should be declared here. You can go for int of in, that is the input variable. After that we are going to check the same thing what we did. So previous is going to be taken the head node. Previous is pointing to the head node because head won't be altered, so you have to take the reference to some variable. After that the current is the variable that is pointing to the next of the head, that is second node onwards we will start the checking because it won't be the deletion of the first node, this operation. So you can start from second node onwards for checking the deletion. So you can go for head of next. Okay, after that we are going to generate the while condition while this current node Current means you should be careful here. Second node we are talking about. Second node onwards we are doing the condition checking. Current not equal to null. Current not equal to null. We are going to check the condition that if what we did in the insertion. No, the similar thing we are doing here. If we are going to take current of data. Current of data equal to IN input. The user is given input is correct. Okay, it will be checking. It will be checking if current of data is equal to in. In means the current node data. Current node we are going to actually remove from the linked list. Okay. So else spot. So when the else spot will come means if the condition is failed, the else spot will come. Else spot we are going to write. We are going to write two things. Two things has to be modified. One is the previous. Previous one is changed to previous followed by next. That means we move on to next node. The previous will move on to the next node. Similarly, the current node will move on to the next. Current equal to current of next. Clear? These are all the statements have to be executed for else case. If the condition is true, we are going to careful what we have to do. The middle node, the current node has to be removed. So we are going to take the informations. So the lines should be very careful. Don't alter these lines. We have to assign previous. Okay, previous node next node. Previous of next equal to the current node next. Current node next. Okay, so previous means the node which is occurred after the removal node. So the previous node next value has to be copied the current node next value. So we will have a connection between previous node to the followed node of the deleting node. Okay, so you can simply after this, so you can simply refer here. So do you want anything else operation? So you can make the connection from this node to that node. That's it. Okay, you can simply go for break. You can come out, no issue. You can come out of this. Okay, so now the current is holding a particular variable, that is current. No, you can simply remove that, free of current. This should be outside of this particular. This should be outside of this particular while loop. Am I correct? Because the break will works now, so you have to write this free of current should be outside of the while. This is for if condition. So this is for the entire while. This is for else part. So free of current, and you can put semicolon, then return of what is going to be return means return of the header. That's it. Okay, so now the function is ready. Next one is next operation is you can go for again node star of delete last, and the node has to be taken as an argument. Node star of. The similar thing will happen here also. We are going to take two arguments. One is called node star of previous, and one more is of current. The same thing what we did in the previous. Okay, now we are going to take what is the previous one. Previous equal to header. Okay, this is header. The next one is current. current one is what? Head of next. We are going to write the while condition. Similarly, what we did there, while current not equal to null, current not equal to null, we are going to check inside. One condition is what? The current is always pointing to the node which is going to be removed. If it is a last node, the next field of the current node should be what? Null. That condition to be checked out here. If current of next equal to null, okay, that time what is happening? So we are going to say that the particular node become a last node. We are trying to remove that. Okay, now the same coding what we did previously, the same we have to do. Previous of next, what is actually stored means previous of next equal to current of next. What is the current of next now? Current of next is null. Current of next. So the null value is actually taken into the previous node because we are removing this node now. So you can go for immediately break. So I don't want to further going through this loop. You can remove else part. Okay, when the else part is coming, we are going to change the reference of the node from one node to another node. So you can write previous equal to previous of next. Okay, similarly current equal to current of next. That's it. Clear? So now what will happen? Now we are having the reference called current. So once the break is coming out, the while loop is terminated. Outside of the while loop, you can go for free of the current node. That means the address is released. Current node address is released. After that, you can go for return of header. Okay. So once go through my video explanation, then you can refer this coding part. You may have some understanding. Okay, so here I left out view operation because the view operation code has been given in the video lecture itself. Thank you, students.